everyone, this is Mrs. Jackson. This is Chapter 2, and we're starting Section 2, and in this section, we're going to be talking about the standard form of a quadratic function. It may look familiar to you from Algebra 1, where you learned how to factor a quadratic. And the standard form looks like f of x equals ax squared plus bx plus c, where the a and the b and the c, they're just placeholders here for numbers. Okay, so they're just coefficients. In this case, c is a constant. And the only qualifier we have to say about the standard form is that a cannot equal 0. Because if a equaled 0, that first term would reduce to 0, and without that x squared, we no longer have a quadratic. So far this year, we've been looking at the vertex form of a quadratic. So how does that relate to the standard form? Well, I'm going to take this vertex form where we have our stretch, we have our left and right translation, and we have our vertical translation here with a k. And I'm actually going to multiply this out using my knowledge of exponents and the distributive property. So here I have f of x equals a, and this base here, x minus h, is being squared. So I'm just going to show that out as the base multiplying itself 2 times. X minus h times x minus h. And then I've got my plus k out here. And now I'm going to go ahead and I'm going to distribute this. And remember, when you square a binomial, you end up with a trinomial out of it. So I have f of x equals a, and I'm going to go ahead and maybe put a bracket here. So x times x is x squared. X times negative h is negative hx. Negative h times x is another negative hx. And negative h times negative h is a positive h squared. All of that is going to see that distribution of the stretch factor a. And on the outside, we still have our plus k. Before I distribute, however, I'm going to combine some like terms. So in the brackets, negative 1hx minus 1hx will give me 2hx. And that's where my trinomial is. And then the last thing I'm going to do is I'm going to go ahead and distribute this a to everything inside the parentheses, or inside the brackets, I should say. So in the end, I have ax squared minus 2ahx plus ah squared plus k. Now let's line this up with the standard form. I've got ax squared plus bx plus c. And I'm drawing this out for effect so that you can see that a is a. No matter what form you take, that stretch factor out front in the vertex form is the same leading coefficient, we call it, in the standard form. And b is equal to negative 2ah. So that's the coefficient in front of that x term. And c is going to equal a times h squared plus k. Okay, in Chapter 1, we've primarily used the vertex form, and the reason for that is it's so convenient to graph the function. Right from the equation itself, you can see exactly what the vertex is. That tells you the left and right translation, the up and down translation, and you can read the stretch right from the equation. So it's extremely convenient to graph from. However, if you're given the standard form of a quadratic, it's not as convenient. You can try to factor it and find the what's called the x-intercepts. We're going to talk about that in a future section. However, you just can't see that vertex or the translations from that format. So it's extremely convenient if we are given that to convert the standards. So I'm going to talk about the steps to convert the standard form, and I'm going to abbreviate standard, to the vertex form. All right, so the first thing we're going to do is, I'll just write out the function here. A x squared plus bx plus c. So the first thing we're going to do is we're going to write down b, whatever that coefficient is. We know that that's equal to negative 2ah, and I want to solve for h because I know that h is my x-coordinate of my vertex. So if I solve for h here, that means I'm going to get rid of this multiplication of negative 2a. And so my x-coordinate of the vertex is going to equal b divided by, I'll say negative b divided by 2a. Now we could use this other relationship up here to get the y-coordinate. If we wanted to solve for k, we could use this, but it's kind of messy. What's easier to do to solve for k is just substitute. So I'm going to say step 2, we're going to substitute this h here. Remember, h is our x-coordinate. Okay, let me just write that. So remember, when we're solving for our vertex, that's x. All right, so if we want to find y, we can substitute h into our function, and solve for the output. That's much easier than using that other relationship. And remember what we're solving for. This y is k. So from that, we'll end up knowing exactly what our vertex is. And finally, a is a, so we already know what a is from the standard form. And you can finally write your function in vertex form. So we'll just pick off that leading coefficient a, and we're going to substitute in our h in our k, and then we have our vertex form. Okay, so in this video, we looked at standard form and how to convert that standard form into vertex form. I hope this helps.